Alright, so in this video we're going to talk about making a T confidence interval for the mean. And remember, we're going to use the T distribution here, because in particular we don't know the population standard deviation. And I'm given some sample data. So this particular problem says, in 1998, as an advertising campaign, the Nabisco company announced a 1,000 chips challenge, claiming that every 18-ounce bag of their Chips Ahoy cookies contained at least 1,000 chocolate chips. Dedicated students at a school purchased and randomly selected bags of cookies and counted the chocolate chips. Some data is given below. So we're given data and we don't have any kind of standard deviation, and we want to go ahead and try to generate a confidence interval for this. So to do that, remember, we have to check three assumptions. Our first assumption is that the data was randomly selected, and that's stated right here. It tells us that the data is actually randomly selected, so we're good there. The second one is the 10% rule, or independence. In this particular case, we're going to say surely there's only 16 values in this, so surely 16 bags of chocolate chip cookies are less than 10% of all bags of chocolate chip cookies that Nabisco company makes. It's another assumption check. The third assumption, which is new for means, is going to be the normality assumption. And we can show normality through three different ways. The first way is the central limit theorem. In order to use the central limit theorem, the sample size has to be bigger than 30. For this particular problem, our sample size is only 16. So remember, if it's not bigger than 30, the other way we can show it through central limit theorem is if they tell us that the distribution is already normal. That's not stated here either. So the third way, and the new way we're going to do it, is we're going to graphically assess the normality. So to graphically assess this normality, we're going to use what's called a normal probability plot. And to do that in your calculator, what you need to do first is, when you're given data, is put this into a list. So we're going to come here and we're going to add a list in spreadsheet. We're going to give this first list, list 1, a name. I'm going to call it chips because we're talking about chocolate chips. I'm going to go ahead and type these values in. You can go ahead and pause the video and type them in yourself if you would like to. All right, now that we have these typed in, the next thing we want to do is we want to go ahead and assess the normality. So to do that, we need to make a graph. In order to do a graph, we're going to add a data and statistics. And if you notice, it'll set up like this, and it'll say click to add a variable. You're going to click here, and I want to add my chips variable, just like this. And now I want to change this plot type. So to change the plot type, I'm going to go menu, number 1, plot type. I'm going to change it to the normal probability plot, which is number 4. If the data is normal, or what we're going to call nearly normal, we want to talk about nearly normal, the value should fall along this black line right here. And what you're doing is you're plotting z-scores in order. And remember, z-scores come from a normal distribution. And so if this value falls along this line that's increasing right here, your data is nearly normal. So we can look at this right here, and we have no reason not to believe the data is not nearly normal. That's how we're going to state it. There is no reason to believe the data is not nearly normal. All right, so now that we know that it's nearly normal, we can go ahead and create the actual interval. So to get to the interval, I'm going to add a calculator. And in this calculator part, I'm going to go menu, 6, statistics, number 6, confidence intervals, number 2, T interval. This is a T interval. The T interval has two ways to be calculated. You can calculate the data, or you can calculate the stats. Data is when you put things into a list like we just did. Stats are when you're given the actual numbers in the problem. So we're going to leave this set to data, press OK. We're going to give it the list. Our list was the chips list. Frequency list, leave it at 1, and your confidence level. There's no confidence level given in the problem, so we default to 95%. Press OK, and it gives me my lower limit, which is 1,187.95 chips, to my upper limit, which is 1,288.43 chips. And then it also gives me other values that I can use to actually make this confidence interval by hand. It gives me X bar, which is the sample mean, and the margin of error. And remember, to find a confidence interval, it's just X bar plus or minus the margin of error. So we could literally add this 50.239 and subtract it and get these two values of the lower and the upper limit here. It also gives me this degrees of freedom. And remember, anytime I talk about a T interval, I will always have degrees of freedom. They're always one less than your sample size. Your sample size here is 16, so your degrees of freedom are 15. And the final thing, if we want to answer this question, does Chips Ahoy contain at least 1,000 chocolate chips? Well, if you look at your lower limit, it's 1,187.95. Your upper limit is 1,288.43. They are both bigger than 1,000, so yes, the claim that they're making based on our data is true. And we can state that as we are 95% confident that the true mean chocolate chips in Chips Ahoy cookies lies in the interval 1,187.95 to 1,288.43.